Hello. Okay. Thanks for having me, and thanks for staying to the very end. I know it's been a long couple of talks. So I'll keep this sort of non-technical. Should be light on technical side, maybe slightly heavy on other topics. We'll see how it goes. So I'm a data scientist. I lead a data science team at Rainforest QA. We do software testing as a service. But today, the talk will be about something totally different. As I deal with sort of AI and machine learning at work, I have started to think, are there some ethical implications to the things that we do? If you have been to any conferences like PyData's or EuroPython's last year, I've been to a few of those, and I thought it was really cool. There were lots of new visualization techniques and a bit of deep learning and machine learning in general. And it was cool, but the topic of ethics was not touched on as much. This year, this really changed. If you've been to, you've seen at this conference and also many others this year, people are really starting to think about this and try to figure out what are the real-world implications of the things we do as data scientists. So I think that's really good. People are thinking about it. There's lots of things that we do actually do have real important impact on the world. Just as a note, as a bonus, there's a couple of references to British pop culture. And if you get something, shout. Before we dive in, I just want to credit a few people that have been talking about things connected to this generally. First of all, you probably all know Catherine. She's a badass. She gave a really good keynote about interpretable models, and she touched on, it's a topic that's very well connected to ethics. But there are also other people. So, for example, Zeynep Tufekci, she describes herself as a techno-sociologist. She has a background in technology. Now she's doing research in sociology. And she talks about the things that I'll talk about today, but also more generally about how technology impacts the world, about how protesting changed with Twitter and Facebook and so on. And finally, Cathy O'Neill wrote this sort of Bible of this topic, The Weapons of Mass Destruction. If what I'm telling you today sounds interesting, definitely go and read this book. It's very scary, but I think a very important read. So I will basically rehash lots of things that they have said before much better. So if you're interested, please go and look them up. Does anyone know what this is? So this is Deep Thought. It's the computer that was built in Hitchhiker's Guide to the Galaxy. And it was built by super intelligent, multidimensional beings to give the answer to life, universe, and everything. So, these super intelligent, hyperdimensional beings basically got fed up with existential angst, and they wanted the answer. So they decided to build this super powerful computer. And when they did, they went to it and say, hey, please give us the answer to life, universe, and everything. At which point the computer said, OK, I need 7 million years to do the computation. But what's a bit of waiting in exchange for such an important thing? So they did. They waited 7 million years. They came back, at which point Deep Thought said that the answer is 42, but it doesn't know what the question is. So, why am I telling you this? It's sort of a silly science fiction story. But I think one of the reasons why Hitchhiker's Guide to the Galaxy is such a funny book is because it has some very pointed criticisms at how our society works and how people tend to think. And this is kind of illustrated in this example. First of all, if your question is rubbish, you will not get a useful answer. And that's probably obvious to every one of you. But it's not always obvious as you work. And there will be an example later on. But second of all, why did the super intelligent, hyperdimensional beings decide to build a supercomputer to answer this question? Why didn't they, for example, decide to create a well-funded philosophy department and sort this out? Maybe it would take less than 7 million years, and maybe they would get an answer that they can actually use. I think one of the reasons they decided to build a computer is because we tend to think that computers are objective. Right? They are governed by ones and zeros and logic gates and transistors and algorithms, and they have no morals. So they cannot be biased, and they're always fair, and they're always true. Now, if you've been to sort of this conference, at least you already know that this is not necessarily the case. So, there might be, computers are not always right. But maybe when they are wrong in obvious ways. Like when CNN misclassifies a cat as a penguin, it's really obvious to us, there's a mistake. It's kind of harmless. It's a bit absurd. We might have a chuckle, so it's no big deal. But there are also cases where you can't actually tell whether computers are wrong or not, whether the answers they're giving you are correct. And also the kind of mistakes that algorithms tend to make are usually very different than mistakes that humans tend to make. And we'll also come back to that. OK, so first of all, is there anyone here that thinks that still thinks that computers cannot be biased? Awesome. OK, part of my work is already done. So I will tell you a little story. You might have seen this already. Does anyone know where this comes from? OK, I'll go over it quickly because there's lots of sources explaining it. But there was an article written in ProPublica last year in 2016. And it was describing the case of these two people, among other cases. So the person on the left, her name is Brisha. And the guy on the right, his name is Vernon. They have both been convicted of a crime in Florida. And Florida is sort of a very specific place in the US in terms of its criminal system, but it illustrates the point very well. So Brisha she was, I think, 18 or 19. She was walking somewhere, and she saw a kid's bike lying on the side of the road. She picked it up. She started cycling on it and then threw it away. Started running away, but the mother of the kid that the bike belonged to, saw her, called the police, and she was arrested. The bike was worth around $80, I think. Vernon was arrested for shoplifting, something of similar value. So they were both arrested, and they were put through the criminal system. And one of the quirks in Florida is that there is this system called Compass that scores the recidivism risk. So everyone who is arrested for some kind of crime gets put through the system, and if the score is high, that means that the system thinks that this person is more likely to reoffend. If it's low, it's less likely to reoffend. And this is still given to the judge, and the judge makes the decision, so it's not that the algorithm is sort of the ultimate judge, but it's still taken into account. In this case, Brisha was given high risk of recidivism. Vernon was given low risk. So that was 2014. By the time the article was written in 2016, we already knew that the algorithm got it wrong. So after 2 years, Brisha did not reoffend, and Vernon did. He was trying to, I think, steal something much more expensive from some warehouse, and he was arrested again. So, maybe it's not a big deal. Like, if we put aside the whole issue of letting algorithms decide anything of importance about humans, which might be questionable as well, but let's accept that for now. Algorithms make mistakes. We accept it. They're not perfect. There's some kind of level of accuracy. They just have to be good enough. The problem is that they might actually be biased in a specific way, and you can probably see where this is going. So ProPublica, their investigative journalists, found that the algorithm is actually racially biased. So while it misclassifies white people and black people at more or less the same rates, it makes different mistakes. So when it misclassifies a black person, it tends to assign them higher risk, and misclassifying a white person tends to assign them lower risk. So after this article was published, there has been some rebuttals and sort of very in-depth analysis. It's a very, again, scary but kind of fun topic to explore and read about. But just a really scary example of how you can take something like predictive policing that seems objective, and I'm sure no one designing the system actually tried to make it racist. It's just the way it worked out. Another thing that I probably don't have to explain, so it's been mentioned at least twice. Even Julia today was talking about word vectors and how they can be biased. Does anyone think, or does anyone agree, does anyone disagree that word vectors can be biased? OK, so we all know they can be. But I think there's still an important point here that bears repeating. The paper that discovered this also proposed ways of dealing with this. So you can, basically, if you have this high-dimensional space of word vectors, you can you can pre-process the training data to effectively sort of squish and stretch the hyperspace in different ways to make sure that the words that you think should be close together are close together, and the ones that shouldn't be are not. But the critical point here is that this is not automatic. We need our human judgment to make this decision. Some relationships, like king and queen, we want to preserve that. But the relationship that that was given in the paper, like computer programmer and housemaker, that's something we don't want to preserve, but it's still in the data. So we have to sort of get rid of our illusion of, okay, we're just objective, we're looking at the data, because the data is biased. Our world is not fair. So if you are saying, if you try to give away this responsibility, you're actually reinforcing biases that exist. So if you want to be fair, you have to do something about it. On a slightly lighter note, I'm sure everyone knows who this is. So, you might say, okay, sure, I've got a data set. There are a bunch of things in there that I do not want to discriminate on, like race or gender or whatever you can think of, whatever is appropriate for the application. So let's just get rid of those characteristics. I'll just drop these columns, and whatever algorithm I use, whatever model I train, will not use them. Well, it's not so easy. You can, for example, if you drop the column containing people's gender, your algorithm might still learn what the gender is implicitly based on name or interests or many other characteristics. So it's actually quite difficult to make sure that your model doesn't focus on things that you don't want it to focus on. And this is important for a bunch of reasons. First of all, you might think that doing some of this, taking decisions based on some of these is just unethical. In many places, there are actual legal requirements. So in the US, there is this concept of disparate impact, and there is an actual formula that you can apply. You treat the algorithm as a black box, and you basically see what goes in and what comes out. And if someone is able to prove that your algorithm is biased in a specific way according to this formula, you can be sued. So it's really important, even if you didn't care about ethics, to think about this. And another example it comes from a talk from Zainab that I already mentioned. She was at some point at the conference for HR professionals, and it was fairly recently. So AI is all the hype, and if you've ever done any hiring, you know that sifting through hundreds of CVs is a huge pain in the neck. So people were really excited about automatically matching CVs to open positions and discarding the ones that are not suitable. So let's keep that on the side for now. There were two papers fairly recently, one based on data from Twitter, one based on data from Instagram, that were able to predict when people will get depressed. Based on your social media posts, these algorithms were able to detect signs of depression before it was diagnosed. Now, imagine that this algorithm for doing job matching uses data from your company, right? You have a bunch of people already hired. Some of them are high performers, some of them are not. And you train an algorithm, try to figure out, okay, I want more people like that and fewer people like that. Even without you knowing, for example, the algorithm might have access to social media. The algorithm might learn that, oh, right, this person got depressed 3 months into the job and they performed terribly, and might discriminate against them without you even knowing that. And that's the scary part. It's obviously very ethically questionable and also illegal to do something like that, but if you just train an algorithm and give it data, it might do that anyway without your knowledge. So that's something that's very important to keep in mind. The other thing that I already kind of mentioned is unintuitive errors, and it's just the idea that the errors that computers make are very different to our human errors. So this year at NIPS is the first time they're organizing a adversarial learning competition. So the aim is to create, let's say, we have a model, like an ImageNet model classifying images into classes. And the aim is to create an image that looks totally fine to a human and gets consistently misclassified by algorithms. So you can add specific noise patterns in different ways to make sure that the cat is always classified as a penguin, for example. And the competition is, on one hand, people will try to fool the models. On the other hand, people will try to create models that are robust to this kind of thing. But the thing is that we as a society have been developing for quite a long time, trying to learn how to deal with our own human biases. Like if you think about how the justice system tends to work, and many other examples, they are kind of built around making sure that human biases are somehow balanced. The same methods don't necessarily work for machines because they tend to make very different mistakes. I promise to come back to stupid questions. Anyone knows this screenshot? Monty Python. So, stupid questions, that was the Knights of the Round Table where had to cross the bridge, and the question turned out to be, what's your name and what's your favorite color? But this is a paper that has also been making rounds a while ago. Just keep in mind that this paper was put on archive, but it was not actually peer-reviewed. So, it's a terrible paper, but at least it wasn't peer-reviewed and accepted. But basically, what they tried to do here is they tried to classify people as criminals and non-criminals based on single facial photograph. The row on the top shows criminals, and the row on the bottom shows non-criminals. So what did this algorithm learn? That people who don't smile are criminals, or people in white collars are definitely not criminals. We know that's not true, right? So it's just important to, and I think they just used AlexNet, sort of put it through a neural net, and it learned something. And it was heavily criticized. So our community is at least somewhat resistant to things like that. But it's still important to keep in mind not to ask silly questions. This is much more recent, from September. It was written by Yilun Wang and Michał Kosiński. Does anyone know Michał Kosiński? Okay, so that's just an aside, but it's also very interesting. Michał Kosiński is a researcher also on kind of intersection between psychology and computer science. And a bunch of years ago, he came up with the method to classify people to predict people's like big 5 personality traits. So there's like agreeableness, conscientiousness, and so on, based on Facebook likes. And that caused Facebook to sort of immediately shut off people's access to this data and so on. But the scary thing was that a few years later, this exact research was apparently used by Cambridge Analytica, which is a company that sort of lobbying and researching company. And apparently they have used similar techniques to influence people during Brexit referendum and presidential election in the US last year. So that just shows you how scary these things can be and how much impact they can have. And again, there are articles about that I encourage you to read about. So this was a much more recent paper by Michał Kosiński as well. And in here, they also divide people into 2 categories. Can you guess what these 2 categories are? OK, let me rephrase it. They categorize both men and women into 2 different categories. These categories are heterosexual and homosexual. This paper was peer-reviewed and will actually appear in a psychological journal at some point. I'm not sure when. It was still heavily criticized. It definitely has problems. So let's just talk about a few of them. I'm not here to sort of pick on this paper. I think it's a very interesting case to think about. First of all, is it ethical to even publish something like this, regardless of whether it's right or wrong? On one hand, you're sort of giving a tool out to people. You might say a weapon, not a tool. And it's very easy to imagine how something like this can be weaponized to actually hurt people. So, it's very morally questionable whether it's the right thing to do. On the other hand, I haven't told you anything about how this is actually done, but most of you can probably imagine, and you can get this data yourself, and you can actually build something like this fairly easily. So the tools are already there. So probably there are already people trying to do this. And releasing this paper might just fire up the debate about this and maybe actually make people conscious of the problem. So maybe it's a good thing to do. It's hard to say. There are also some sort of flaws in the paper. They try to make sure that they don't take into account things like, the angle at which you take your selfie and the environment you're in and the grooming style of your face and so on. But I think it's very difficult to actually do. So it's hard to say whether the model is picking up on actual facial features, like width of your nose or whatever, or something that doesn't actually tell you anything about the human, but about the human, how their face looks like, but like how they live. Okay, last thing I want to mention is the power of the machine. So that might be fairly obscure here. This is from a show called Little Britain, and this is Carol. And Carol is a receptionist, and she sort of helps people in like banks and hospitals, and whenever someone comes over to get help, to sort something out, she does a bit of that, and that says, computer says no. And it just, it's really silly, but it just illustrates that these things that we have built that were meant to make our life easier and make us faster and more efficient and happier are sometimes just roadblocks in what we try to do. And if the computer says no, you can't argue with it. You can't convince it to say something else. And Carol might not have the power to actually help you. And this applies everywhere. So Catherine has a really interesting talk at EuroPython this year, also a keynote, where she mentioned automatic check writing system. So at some point in some bank, can't remember where it was, they developed a method to write checks automatically. And suddenly that was amazing because they could, it was just the time when they wanted to expand, and that allowed them to actually expand and be much more efficient and so on. And that's great. But maybe if they didn't have this option, if they didn't have computers, maybe they would have to innovate in a different way. Maybe they would have to change the organizational structure, maybe have to decentralize, maybe hire more people. There are different opportunities. And even though technical solution might be great, I think we should think about other ones as well, just to make sure we're not taking the easiest way out that is not necessarily optimal. So what I would like you to do as you're building machine learning models is, first of all, read up on this topic. There are lots of references that I'll try to put a link to afterwards. Read about it, start thinking about it. Whenever you're building a machine learning model, consider the impact it might have on the world, whether it's actually doing what you think it's doing. Maybe join a meetup specific to that. Maybe join a political party if you care about it. The message is that we are not objective in our work, and what we do has real implications on the world. So computers can be assholes because we make them, so please don't. Thank you.
Thank you so much for that talk. I think it was very inspirational, especially 42. Yeah, and in fact, during the tutorials, I had a short discussion over the image recognition, and we discussed briefly the problem, or like the idea to find the sexuality of the person based on the face, right? But I didn't know it was already done, so.
Yep.
All right. So, okay, you have questions to our speaker? Yeah.
Okay, perhaps you know this paper about, actually it was a blog post, that if you train word2vec, by default is racist, sexist, etc. So for example, if you have nations and say, I don't know, like good versus bad, and you get, well, some more expensive, more rich nations as good,
right,
and other as bad,
sure,
for example. And this, but for me, what is curious is how to create a human baseline. Because, well, it may happen that machines are like say east in various aspects. The question is if it's an improvement or our own performance. Sure. So I guess juries also are heavily biased in the US. And is it question, does it amplify it or reduce it, or is it the same?
Sure, it's a great question. I don't think there is the right answer. It really depends on the data you use and the application you use it for. Like, if you want to just explore biases that we have, like pre-trained word2vec is awesome because it shows you exactly that. So it's the right tool for the job. But for other cases, it might not be so. And I'm not trying to say that you shouldn't use algorithms. You're right that in some cases, even algorithms, they might not be perfect. They might still be biased in some way. But if they're better than humans, maybe that's good. But what I am trying to sort of fight is the perception of algorithms are objective and have no morals. They do have embedded morals in them. So it's just important to consider that and try to counteract it.
Okay. And okay, maybe one more question, and this one is actually a silly one, very silly. When it comes to like criminals, is there something like hallucination? So you have some dreamed criminal and dreamed innocent person when a machine tries to, well, abstract.
That would be interesting.
The most face.
So, I mean, I suspect probably. And it's kind of funny that when you read this paper about detecting sexual orientation, it sort of, the first thing they do in the introduction is saying, you know, was it phonetics or physiognomy? Is you know, this thing is terrible, and it's I can't remember the name. Is this area that was really popular, sort of pseudoscientific, as we now know, that was really popular in the 18th century, where people were trying to predict, oh yeah, this is a criminal because you know his nose is wide or whatever. It turned out that it's all sort of racism and other biases hidden behind pseudoscience. So this is the first thing they claim in the paper because they don't want to do that. But at the same time, there are things that might actually link character to faces. For example, I mean, I'm just basically rehashing what they said. People who are attractive are, tend to be perceived differently by other people. So their experiences with people are different. So that might develop their character just because of how they look like. So there might be at least this link between face and character. And there might be many others. It doesn't mean that it's not as trivial as like big forehead or small forehead, but there might be some links. So to link back to what you said, maybe in different countries, because of cultural differences, these relationships are slightly different. And they might manifest themselves in different ways. Some of them might affect how people actually look like. But it would be a really interesting research to do, like create an eigenface of a criminal per country. I'm not aware of that, but I guess it's an opportunity.
Okay, so thank you.
Okay, any more comments or questions? There's one.
First thing, actually, I had a comment about the criminal face. I think I read an article where they took like a whole bunch of pictures of criminals and then just like set them one on another and took like this sort of, I don't know what to call it, like a mix. And it actually turns out to be kind of like an average good-looking person because just sort of everything sort of kind of evens out and then you end up with somebody that's just sort of, oh, it's just a person.
Surprise, surprise.
But actually, my question is more towards where do we stop like eliminating features and keeping it like having the algorithm actually work right and keeping it ethical? Because let's say, okay, so we get rid of gender, we get rid of race, so then maybe the algorithm makes the decision on age. Well, then that's ageism. Then, so we get rid of age. So, I don't know, we look at how people are dressed, and we see that people who wear jeans create more crime than people who wear slacks. Hey. So do we get rid of that? I mean,
no, I get your point.
Where's the line? And I mean, if everything is evenly distributed, then we can't really make a classifier anyways. So
sure.
How do we deal with this ethics and, a good classifier?
Sure. I mean, that's definitely an open question, and I think it was one of the points that Catherine was trying to make the keynote yesterday. That there are so many open problems here that the field is ripe for picking. But there are some suggestions, like this idea of disparate impact is one that's sometimes applicable. So you have to, but again, it's not automatic. You have to apply your human judgment, and you say, okay, these are the values I believe in. I want my algorithm to do this, and I'm going to check it against that. There's no way to say, just make it unbiased or check it. You have to know what you're looking for. But this disparate impact thing basically treats things as black boxes, and if you can sort of vary the inputs, try to perturb, for example, race or gender, or it depends on what you're classifying, and see what comes out. Like if everything, let's say every sample that has a specific gender is misclassified in a specific way, you have a problem. So the best answer I have is just think of how it could break, how it could be biased, and try to find it. I'm sure there are many other things we could be doing, but we need people to actually find those.
Okay. Any more questions? I think that we can try to make this topic a little bit more longer, like make a longer presentation during our meetup, like
cool.
to the next one, or think about it and we can do the discussion afterwards. That might be a good like a ending presentation, but then a discussion afterwards. So if you if you have an idea how to, for example, contribute to this, you can like join one or something like that. All the ideas are open. So thank you so much.
Thank you.